Alright, so if you have a function that is a line or even a function that is a parabola, both of these functions have no restrictions on their domain. So their domain just goes from negative infinity to positive infinity. Alright, so what about the functions that have restrictions, and where do they exist? Alright, the first case where we have a restriction on our domain is going to be a fraction. So the reason why we have a restriction on our domain here is because if you ever have a case where you have any number over 0 that is undefined. So that means we cannot have any values here in the denominator that equal 0. So factoring that will give me x plus 2 times x minus 2. That's the difference of two squares. So the values that I am not allowed to have, x cannot equal 2 and x cannot equal negative 2. Those are outside of the domain. Now, you can write it this way, or using interval notation, go from negative, the smallest, to the positive. And I'm going to go ahead and do this on the number line. I think it's the easiest way to go through and learn how to write interval notation. So if this is my number line, what I'm saying here is x can be everything, but it can't be negative 2 and it can't be 2. Every other place on your number line it is allowed to be. So let's go from the smallest side to the largest. So starting on this end, that's negative infinity. I can't be at 2. And then I can't be at negative 2, excuse me. And then I can't be at positive 2, going all the way to positive infinity. So to write that in interval notation, that would go from negative infinity is allowed, all the way up to negative 2, but negative 2 is not allowed. They both get parentheses. I union that, which means also I add in the next interval, which goes from negative 2 to 2, and then back again from 2 to positive infinity. Now, the next case where I have a restriction on the domain is, this is case 2. And this is going to be anytime you have a radicand that has an index of an even number, whether it's 2, or it could also be a 4, or any even number as your index. When I have that, the restriction on your domain is everything that is underneath the radical, meaning all of inside here, that absolutely must be greater than or equal to 0. So if I go through and solve that, I will get 3x must be greater than or equal to negative 2. Divide both sides by 3. X must be greater than or equal to negative 2 over 3. If you want to write that in interval notation, again, I think the best way to think about interval notation to make sure you get the order in the right place is to think about drawing a number line, and this is included, open circle going towards positive infinity. So to write that, you write it in the same order you see in the number line. It goes from negative 2/3 all the way up to positive infinity. And this is definitely a bracket on here because that 2/3 is included. Now, the last one we're going to do is a combination of both of those. So by a combination of both of those, what I mean is what happens if I have the example of a radical and a fraction. So in this case, it's the same idea. I'm not allowed to have a 0 in the denominator. I'm not allowed to have anything underneath that radical be negative. So instead of saying that is strictly greater than or equal to 0, I change this to only x squared minus 16 must be greater than 0. When that radical is in the denominator, you're not allowed to set it equal to 0. Now, if I solve this one a different way than I did before, I can say x squared must be greater than 16. Now, writing this as an inequality can help, because I want to go through. So whenever the inequality is greater, think of that as great or, and you write an or statement, because when you take the square root of both sides of this, I need that or statement. I need to say that x is great or than 4, or x is less than negative 4. Let's talk about this, and as far as number line is concerned here, this is 0, this is 4, this is negative 4. So what this is saying is that anything not equaling 4 but larger will work. Anything that is negative 4 and smaller will work. The way to write that as an internal notation goes from negative infinity to negative 4. But I have to add in that next part of it, which is why I use the union symbol, and I go from 4 to positive infinity.